Welcome to Marine Gurukul video series. In this video, we shall learn about position circle by raising, dipping of lights and first sighting, last sighting of lights. Now we discuss position circle by raising or first sighting of lights and dipping or last sighting of the light. Under this concept, we use the maximum distance or range at which a light is first seen when closing in or last seen when the vessel is moving away from it. The circle is drawn with the position of the light on chart as its center and the first or the last sighting distance or range as its radius. For any light to be visible to the observer, it needs to simultaneously satisfy the following conditions. It must be within the geographical range of the observer, and two, the observer should be within the luminous range of the light, referred to as present luminous range. So it's important that first we understand the geographical range and the present luminous range. Geographical range of a pair of observer and the object depend on their respective heights. As you can see in this diagram, we have a light of this much of height. Now it has its range of sea horizon, which is this much of distance. What does it mean? It means that if there is an observer at sea level, the maximum distance at which the observer at sea level can see this light would be this much. Likewise, we have an observer with this much of height of I, and his range of sea horizon spans up to this point. It means any object which is at sea level, the maximum distance at which the observer can see that object at sea level would be this much. Now the sum total of range of sea horizon of the object and range of sea horizon of the observer is what is called as the geographical range for that particular pair. It obviously depends on the height of the object and it also depends on height of I. This geographical range can be calculated in nautical miles by a simple formula 2.095 into square root of height of the eye or height of the observer in meters and plus 2.095 into square root of height of light in meters. The geographical range so obtained would be in nautical miles. So please be careful about the units. Geographical range shall be in miles. Heights have to be in meters. That's how this factor of 2.095 shall be justified. Now, present luminous range of a light is the maximum distance at which a light can be seen by the observer depending on the brightness or the luminous intensity of the light and the transparency of the intervening medium, which in this case is the atmospheric visibility. Luminous intensity, as far as navigators are concerned, is taken care of by what we call as the nominal range. And the nominal range is the charted range of lights on the present day navigational charts. Atmospheric visibility at sea can be assessed or estimated by the navigator. In examination conditions, the visibility has to be provided in the question. Then we need to understand a term, nominal range of a light. It is the distance at which a light can be seen because of its luminosity under meteorological visibility conditions of 10 nautical miles. It is this nominal range which is charted on today's or present day navigational charts. PLR, that is present luminous range, is obtained by using a luminous range diagram wherein you enter with nominal range and atmospheric visibility. This is how the luminous range diagram looks like. You can see on top here you have the nominal range in C miles, and here on the y-axis on the left hand is the PLR, which is luminous range in miles in prevailing visibility conditions. It can be entered with intensity in candelas, but our charts don't have this. This information is there in list of lights. What you'll get from the chart would be the nominal range. So now let's look at drawing a position circle by first or last sighting through this simple example. Hook headlight was first sighted at 2000 hours in atmospheric visibility of 2 miles. If the height of eye was 12 meters, draw the position circle at 2000 hours. Let's first identify hook headlight on the chart, and from there we pick up its characteristics and we use the information as needed. Now on the chart, here is the hook headlight. We pick up its characteristics, and characteristics are here. Flashing 3 seconds, 46 meters, that is the height, 23 capital M is the nominal range, and horn to 45 seconds. So the charted height of the hook head is 46 meters. Nominal range of hook head is 23 miles. Now we learn to calculate the GR and PLR. Now, if you come to this part of it, we have these informations out here. This is the luminous range diagram. So we calculate GR and PLR. Now GR is equal to 2.095 square root of height of eye, which is 12 meters, plus 2.095 square root of 46, which is the charted height, and we get a GR of 21.5 nautical miles. Now we use this luminous range diagram with this nominal range of 23 miles and visibility of 2 nautical miles given in the question to get the PLR. You can see here from 23 miles we come down to 2 miles visibility curve, and from here we go to the y-axis on the left side, and from here we read off the present luminous range, which is 6.7 nautical miles. So we get GR of 21.5 nautical miles, PLR of 6.7 nautical miles. The light shall be visible to the observer when both the conditions are satisfied. Now both the conditions shall be satisfied at the lower of the two. So at 6.7 nautical mile, both GR and PLR shall be within the geographical range, and it shall also come within the present luminous range. So the first sighting range for hook head would be 6.7 nautical miles. So now we can draw a position circle with hook head light as the center and 6.7 nautical miles as the radius, and you can see this position circle on the chart. This is the position circle we get. Now as far as exams are concerned, sometimes they use the word first sighting, last sighting. Sometimes the terms used are raising and dipping. Please do not get entangled into the technicalities of the terms. If you have all the information available, then please calculate both geographical range as well as present luminous range and use the lesser of the two. To calculate geographical range, you need to know the height of eye or height of observer and the height of the object, that is height of the light. Height of the eye has to be either given in the question or could be given on top in the general remarks in the question paper. Height of the light can be used from the chart. On ships, you will always know your height of eye, which is always displayed in a table at the chart on the chart table against the draft of the vessel. Now, as far as the present luminous range is concerned, you will be able to calculate it in exams if you know the atmospheric visibility and the nominal range. Nominal range in most cases can be obtained from the chart from the light characteristics. Visibility needs to be given in the exams. In an exam scenario whereby you may not have sufficient information to calculate both GR and PLR. Now in that case, please calculate the one which you are able to calculate, and without worrying about the technicality of the terms dipping or dipping, raising, citing, first citing, last citing, use the range that you are able to calculate, and this you are using under the assumption that the other one is definitely more than what you have calculated. So I hope now you'll have no confusion as to which range to use if the term used is raising or dipping, and which one to use if the term used is first citing or last citing. I hope this has been of some value to you. Please feel free to send your feedback on marinegurukul@gmail.com. If you need any further support from us, please do feel free to reach us on marinegurukul@gmail.com. Thank you for watching this video and have a nice time. Bye bye.